Okay, now that we've talked about some probability, let's talk about what we mean when we say odds. So before we do, let's just go over a few of the academic language that we talked about already. So let's first recall what we talked about with event A, right? An event A, a lot of times we say, well, that's the probability that A is going to occur. So our notation is P of A. And if we talk about the complement of A, we say, well, the notation for complement is an A bar. So probability of event A means if we take the universal set and we subtract out the probability of A occurring, then we get the complement. So things to note. Well, let's do it down here. So if I take the probability of event A happening, that's exactly the same as the guarantee that it's going to happen, all cases, minus everything that is not A, or the complement. And similarly, if I want to talk about the complement, remember now the complement is everything that is not in A. So that's the same as saying the guaranteed entire probability minus the probability of A. Okay, so just remember the complement is every element that's in the set that's not in A. So the definition of odds, I'm going to first give it to you by formula, and then we're going to put it into words. Okay? All right, so wonder if I have enough room. I think I'll do it over here, and then I'll go back and we'll put some examples in. So the definition of odds, what we mean by odds. We either have odds in favor or we have odds against. So the first thing we need to do is say, all right, let's let the probability of A be the probability that the event A occurs. Event A occurs. Okay? And let's let the probability of the complement be the probability that event A does not occur. I'll even do this. All right. Now let's take a look at odds. Then odds in favor of A occurring all right. So that means if it is occurring, that means the probability of A over the probability of everything not in A. So you could say that's the same as the probability of A over 1 minus the probability of A. Because the complement is everything that's not in A. So start with the entire amount and subtract out the probability of A. Okay. Now, if we want to do odds against or odds not in favor, so sometimes we call that odds against event A occurring. Okay, now this time we want the complement because we want it odds against that. So if against that, that means it's the complement. So this would be the probability of the complement over the probability of A. So the complement again, and we're going to practice some examples. So right now, I'm just giving you the definition so we can take a look at it. Now, okay, some of you like formulas. Some of you are like, that is really confusing to me, so let me put it into words also. All right. So odds in favor. Another way to think of odds in favor if you prefer to think of it in terms of words, think of it as the number of favorable outcomes out of the number of things that are not favorable. So the number of favorable outcomes divided by the number of unfavorable outcomes. And again, we're going to look at some examples which will help. If I want to put odds against, I'm going to put that in words as well. So if we're looking at odds against, let's write it down here. Odds against event A occurring. Think of it as the number of unfavorable over the number of favorable. The number of unfavorable divided by the number of favorable. So I've tried to give you a lot of ways to think about odds. One way is by formulas. So here's the set of formulas, if you want to think of it this way. So if I put those in a box, here's your formulas. Others of you may prefer seeing it with words. Okay? So what we're going to do is we're going to take a look at an example, and we're going to see if this helps once we actually look at an example. And again, we're going to be referring to the rolling of die that we've done in the past. So if you need to get out that sheet that has all the possible sample set of rolling 2 die or rolling 1 die. So here we go. Let's say our event is, let's roll a standard die. So it's got 6 sides. So we already know, let's just practice for a minute, okay? Let's first find the sample space. Now remember, the sample space was the set of possible outcomes. So sample space and outcomes are synonyms. So the only way you can roll a die is it could land with a 1 up or a 2, a 3, a 4, a 5, or a 6. So those are our possible outcomes, which we call the sample space. Okay, now let's do the following. Let's practice some odds. Odds are different than probability. Let's say we want to roll a number less than 5. So let's find the odds of rolling a number less than 5. So that would mean in favor of rolling a number less than 5. Okay. So yes, I can look at the formula, the probability of rolling a number less than 5 divided by the probability of its complement. I could also look at it in terms of words. Odds in favor of rolling a number less than 5. What are the number of ways of rolling a number less than 5 divided by the number of ways that you don't roll a number less than 5? So I'm going to use the definition and show you how the definition works. Okay, So if I take the probability of rolling a number less than 5 over the probability of not rolling a number less than 5. Now I'll put it in words. Probability that the roll is less than 5 over the probability, well, if it's not less than 5, then that would have to be greater or equal to 5. Well, how many ways can we roll a number less than 5? I have 1, 2, 3, 4 numbers that I could have that are less than 5 right here. So this would give me 4 out of 6 ways to roll a number less than 5, divided by how many ways can we not roll a number less than 5? 2 out of 6. I'm going to go across to save some space. To refresh your memory from elementary school, this is the same as 4/6 divided by 2/6. Division is the same as multiplying by the reciprocal. So the division changes to multiplication. 2 over 6 becomes 6 over 2. 6 is reduced, and we're left with 4 divided by 2, which is 2. Now when I reduce, I would reduce to 2 over 1. So this gives me 2 over 1 odds in favor of rolling a number less than 5. So your odds are 2 to 1 because this reduced down to the fraction 4 over 2, which reduces to 2 over 1. So I just wrote it, instead of a fraction, I wrote it as a ratio, 2 to 1 odds. So let's try it again, but this time let's do odds in favor of, I'm still rolling a die. So odds in favor of, let's do another one. Here, I'll just do the following. Odds against rolling the number 4. So odds against mean we want the complement of rolling a number 4 over the probability of rolling a number 4. Because this time it's against. So that's the same as saying the probability of not rolling a 4 over the probability of rolling a 4. Because against, remember, talks about using the complement. So how many ways is it not a 4? Well, if it's not a 4, it's a 1, 2, 3, 5, or 6. So there's 5 ways of it not being a 4. How many ways can it be a 4? 1 out of 6. Again, this is another way. How many ways not being a 4? 5 to 1. That's the same as 5/6 divided by 1/6 if we do the same arithmetic. So you could say the odds against rolling a 4 are 5 to 1. Or you could write it as the ratio 5:1. 5 to 1 odds against rolling a 4. All right, let's take a look at using a coin with a head or tail, and let's practice again. Okay, so I'm going to leave the definitions over there so we can look at them, but let's look at an example that involves flipping a coin, and then we'll look at an example that involves some cards so that you can really get the idea of what odds mean. Okay, so let's do this one. What you're going to do is you're going to flip or toss a standard coin. Now remember, in here we talked about theoretical probabilities. So the only sample space that we're going to have is going to be, in theory, you can get a head or a tail. So we're not going to worry about landing on the edge in this class, okay? All right, so let's find the odds in favor of tossing a head on a coin. Find the odds in favor of tossing or flipping a coin and having it land on heads. Now, if it's in favor, we want that to occur. So we want the number of ways it will occur divided by the number of ways it will not occur. That's the same as saying the probability of the event divided by the probability of not the event. Okay, so I'm going to put it in words this time. So the odds of tossing a head is going to be the number of ways you can toss a head divided by the number of ways it is not a head. Okay? Now I'm going to do this with number of ways. I'm going to do it with the probability. Well, if you flip a coin and the only outcomes are heads or tails, how many ways can you get a head? There's only one way you can get a head. How many ways can you have not a head? Well, the other option is tail. There's only one of those. So we have odds of 1-to-1 odds. Odds, not probability. We have odds of 1-to-1 tossing a head. If you want to use the definition of probabilities, it would be the probability of flipping a head over the probability of its complement, or not a head. So if I write it as the probability of flipping a head over the probability of not a head, that would be the same as the probability of a head, and in our case, the complement would be getting a tail. So the probability of getting a head, 1 out of 2, divided by the probability of it not a head, 1 out of 2. Anything divided by itself is 1, or you could always say 1/2 divided by 1/2. Whenever you divide fractions, the first fraction stays the same, and by definition, division means to multiply by the reciprocal. And now you can see that when I reduce, the 2's reduce, and we are left with 1-to-1 or 1-to-1 ratio. So whether you use words to describe it or whether you use probabilities, we end up with the same result. Okay? And I'm going to do one more example of odds. And then we'll also take a look at some probability and odds, kind of mix them up. Make sure you really get the differences down. So let's look at our standard deck of cards. So if you need to look at your deck of cards page so that you have all the suits. So there's 52 cards in a deck, 4 suits. Each of the suits, hearts, diamonds, clubs, spades, have ace through 10. And then each one has a jack, a queen, and a king for their face cards. So each suit has 13 cards in it. All right, so let's take a look at this one. Given a standard deck of cards, and I'll even say this, a standard deck of 52 cards. Now in the future, I probably won't tell you that there's 52 because that's considered a standard deck. Okay. Let's find the odds against drawing a club out of the deck. Find the odds against drawing, meaning selecting, a club. So if somebody had a deck of cards and they fan them out and they say, okay, find the odds that you won't draw a club. You won't get a club. Now if I annotate this, I'm looking at odds and I'm looking at against. So that means I want it not to happen. So that's the same as the probability, since it's against, of not being a club over the probability of it actually being the suit of a club. Now remember, we said there's 4 suits. We said there's 4 suits. You may or may not need to write this down. 4 suits in a deck of cards. So just to help those that aren't familiar, we have hearts, diamonds, spades, and clubs. And remember, we have 13 of each of those. We have the ace through 10, and then we have a jack, king, queen, the 3 face cards for each of these. So that's how we get our 52 cards. So let's think of the number of ways that it is not a club. Well, the number of ways that it is not a club would be hearts, diamonds, or spades out of the number of ways that it is a club. Well, there's only one way it can be a club. So we would say we have a 3-to-1 odds against being a club. Whoops, not a cub, a club. Okay, so hopefully that helps. Hopefully by putting it into words, that might help. Okay, now we talked about how odds are found by taking the entire set and subtracting the complement, or the complement is found by taking the entire set and subtracting your event. All right, so let's take a look at this. And I'm going to write it down again. I know we already did. Probabilities are percentages. Probabilities always are between 0 and 1, inclusive. So if you remember what we talked about before, sometimes we have the probability that something is impossible. It is impossible that January 1st, 2021 will happen again. So that's a guaranteed probability of 0. And probabilities fall between 0 and then a guaranteed probability that it is guaranteed to happen. So we can never have a probability larger than the number 1 or greater than the number 100%. Okay? Now, we did say, and let's think about this. So the probability that an event occurs and the probability that the event will not occur, meaning the complement, will always add up to our entire universal set, our entire sample space. This is guaranteed. Guaranteed. If I add the 2 things together, I'm guaranteed to get the entire set. Okay? So keep that in mind. So if a probability that event A occurs is 8 out of 11, okay, so we're just going to say some event that happens. The probability that an event happens is, oops, that event A occurs or happens is 8 out of 11. So if I give you 11 items or 11 times, 8 out of those 11 is what we're looking for, is the event. Okay? Now for those that are visual, you could think of this. Here's your universal set. 8 out of 11, so our universal set has 11 pieces. 8 items have the event happening. So my question to you is, what's the probability that the event will not occur? And you may have already figured it out, but I'm going to write it down anyway. Well, so here's my event A. So I should have actually called that set A, event A. So if 8 of them occur, well, if we have a total of 11, that must mean we have 3 items that are not in A. So they're outside that set. So they're in the complement. That's called the complement, anything that's not in that set. So what's the probability? Now remember, probability is always a fraction. What part out of the whole? So the probability that it will not occur would be saying the probability of the complement. So since there's 3 out of 11 possibility, that would be the probability of it not happening. Probability is a fraction. What part out of the whole? Now look at if I change the words. What are the odds in favor of A occurring? What are the odds in favor of event A occurring? Now let's think about this. Now we're talking odds. Odds is not part of the whole. Odds in favor would be, if I wanted in words, the number of ways event A occurs, not the total number, that would be probability. Odds would mean the number of ways it occurs divided by the number of ways it does not occur. So in this case, the odds in favor of it occurring, how many ways does event A occur? 8. How many ways does event A not occur? Well, whatever's left over. We know there's 11 of them in the set. So if 8 are in favor, 3 must not be in favor. So we would say 8 to 3 odds. 8 to 3 odds in favor. So it's important not to try not to get probability, which is part of a whole, confused with odds, which is the part for divided by the part against. Okay? So let's keep going. Let's see. Let's find the odds against A occurring. Oops, I think I'm running off the board. What are the odds against event A occurring? Now this time we want odds against. Odds are not part of a whole. Odds against. So odds would be the probability of A occurring out of the probability of A not. Whoops, sorry, I just did it backwards because it said odds against. So we want the number of ways, here I'll put it in words again. The number of ways A does not occur, because it's against. Now it's not probability, so we don't want the total number. We want the number of ways A does occur. So how many ways does it not occur? Well, I know it occurs 8 times, which means the other 3 out of the 11 are not A. So you would say there are 3 to 8 odds against. And you'll notice if you add them together, how many ways they do not happen, how many ways they do happen. If I add those together, I end up having the universal set of 11. So that's what we mean way back here. Probability that it does occur plus the probability that it does not occur should guarantee all your choices. So this problem is similar, this particular example is similar to your homework number 20. So this is like number 20 in your homework. So when you get to number 20, maybe come back and look at this one again if need be. All right, so let me give you an example that's similar to number 22 in your homework. So here's a problem similar to number 22 in your assignment. Okay, you might want to write that down. What are the odds in favor of rolling double ones on a single roll of a pair of die? So this is very similar to problem number 22 in your homework. What are the odds in favor of rolling double ones? Snake eyes. On a single roll of 2 dice or a pair of dice. So you're holding 2 dice in your hand. You roll the dice one time. You just roll them once. We want to know what the odds are, what the odds in favor of rolling a 1 and a 1. Okay, so we want to roll a 1 and a 1. So I need to look at the number of ways I can roll a 1 and a 1. Since it's odds, we want the number of ways to roll a 1 and a 1, because that would be double ones. Now, if it's probability, it's out of the total, but it's not probability. It's odds. So the number of ways we can roll a 1 and 1 against or divided by the number of ways not to roll a 1 and a 1. So if you have that piece of paper with all 36 combinations, well, how many ways can we actually roll a 1 and a 1? There's only 1 out of 36 ways. How many ways can we roll anything else? Anything else? Well, we already used up 1, so that means there's 35 other rolls out there that are not a 1 and a 1. So the odds would be 1 to 35 in favor of rolling a 1 and a 1. Okay. So you kind of have the idea. The last example, let's take a look at, you're going to roll 2 die again. Let's find the odds in favor of rolling the sum of 4. Find the odds in rolling the sum of 4 on a single roll of a pair of die. So I'm first going to come up with the sample space, okay? I first want to come up with the event. All right, so let's take a look at this sample space. I like writing that down. Now, if you have that, that piece of paper that have all the possible ways of rolling 2 dice, we could count, but we're looking for a sum of 4. Well, if I roll 2 dice, I could roll a 1 and a 3, and that would add up to 4. Or I could roll a 2 on the first die, a 2 on the second die, or I could roll a 3 on the first die and a 1 on the second die. But those are the only ways out of 36 possibilities that I could roll and add up to 4. So now we go back and we're looking at, okay, we're looking for odds, not the probability, so we're looking for odds. So we want number of ways we can roll a sum of 4 divided by the number of ways we cannot roll a sum of 4. This is odds. Number of ways to roll a sum of 4 number of ways to roll not a sum of 4. That's what we mean by number of favorable. That's what we want, divided by the number of not favorable or unfavorable. So how many ways can we roll a sum of 4? Well, we came up with 3 ways. How many are left to make up that entire chart? Well, since there are 36 possibilities, there are 33 ways to not roll a sum of 4. If I reduce that fraction, divide both by 3, so I end up with odds. It is 1 to 11 odds in favor of rolling a sum of 4. So hopefully you have a better understanding of the differences between odds and probabilities. Okay? So hopefully that helps. Give it a try. See how these goes. See how these go. Bring all questions back to class or send me a remind. And I'll see you next time.